the recording. All right, so the Morse theorem states that for any real number n, so this works for what? All right, I don't like to write and work out with the same color ink. So let's change the ink. So for any real number n, the Morse theorem says that cos theta plus I sine theta raised to the n power is equal to cos n theta plus I sine n theta. So the Morse theorem, that's cos theta plus I sine theta raised to the n power is equal to cos n theta plus I sine n theta. That's the Morse theorem. Example 27 is asking us to prove the Morse theorem for any positive integer n. All right, and the proof that would use here is to use the proof by induction. I'm not going to do that. The proof we'd use here is to use the proof by induction. We could come back to it if we have time. All right, now this is important. This is the idea of the Pascal triangle. And here I wrote that the Pascal triangle is used to determine the coefficients, coefficients in a binomial expansion. The Pascal triangle is used to determine the coefficients in a binomial expansion. All right, so the Pascal triangle is to the left and in blue ink. It's not very difficult to come up with. So I'm going to do it over here and then erase it. So you have 1, and then you have 1 and 1 here. And then here you will put 2, because 1 plus 1 give you 2. You put a 1 here and a 1 here. Then 2 plus 1 give you 3. 2 plus 1 give you 3. You put a 1 here and a 1 here. 3 plus 3 give you 6. You put 6 here. 3 plus 1 give you 4. 3 plus 1 give you 4. You put a 1 here and a 1 here. 4 plus 6 give you 10. 10. 4 plus 1 give you 5. 4 plus 1 give you 5. You put a 1 here and a 1 here. So this is how, and the Pascal triangle, you can go down with it forever and ever and ever and ever and ever. All right, so how now does the Pascal triangle relate to a binomial expansion? So here's a binomial expansion, and it's related to this level of the Pascal triangle. And the level here, so if I need to expand a plus b squared, the coefficients according to the Pascal triangle would be 1, 2, and 1. So the answer here would be a squared, where the coefficient is 1, plus 2ab, so the coefficient in the middle would be 2, plus b squared, the coefficient at the end would also be 1. That is what it is saying. All right, let me do another one. The expansion here, what the Pascal triangle is saying now, for this level, if I expand a plus b cube, if I expand that, the coefficients are going to be 1, 3, 3, and 1. So first you're going to start off with a cube. Then plus the next coefficient is going to be 3. So this is 3. Please note what is going to happen next. The power of a is going to decrease while the power of b starts to increase. So the power of a, the first one was a cubed. So this is going to be a squared b. The next coefficient is going to be 3 again. So this is what? 3. The power of a decrease and the power of b increase. A b squared. And then the last coefficient is going to be 1. And this is what? B cubed. Now, if I want to expand a plus b to the what? 4th power, and being assisted by the Pascal triangle, this would be, the first coefficient would be 1, and the last coefficient is 1. So the first coefficient and the last coefficient is always 1. So this is going to be a to the 4th power plus 4 a to the 3rd power. So the power of a starts to decrease and the power of b increase. Plus 6 a square b square, power of a decrease, power of b decrease. Plus 4 again, 4 a b cube, and then now the last one, the coefficient is 1 b to the 4th power. All right, and this is essentially work. At this level, it's going to be a to the 5th power plus 5 a to the 4th power b plus 10 a to the 3rd power b square plus 10 a square b cube plus 5 a b to the 4th, and then lastly this is what b to the 5th power. So this is how Pascal triangle could assist you in determining the coefficients of every term in a binomial expansion. I could do a to the 6, it's just as easy, but I'm going to stop there. All right, so this is example 28. It says express cos 3 theta and sine 3 theta in terms of theta and sine theta only. All right, to do this, I'm going to use the Morse theorem. Now, if I use the Morse theorem, let me try and get something going with the Pascal triangle. 1, 1, 1, 2, 1, 1, 3, 3, 1. All right, I don't need to go any further than that. The Morse theorem says that cos 3 theta plus I sine 3 theta, the Morse theorem saying, sorry, I don't need the brackets there. It's saying that this is equal to cos theta plus I sine theta cube. This is what the Morse theorem says. All right, in the page before it, we had it the other way around, but it's the same thing. So what I'm going to do now is I'm going to do a binomial expansion to say that cos 3 theta plus I sine 3 theta is equal to, using binomial expansion, this is going to be cos cube theta plus 3. Now the power of cos is going to decrease and the power of I sine is going to increase. So this is cos square theta multiplied by I sine theta. Then the next one is going to be 3. The power of cos is going to decrease further, cos theta, and the power of I sine theta increase. I sine theta square. And then lastly, the power of I sine theta alone. So it's I sine theta cube. All right, so we're using the Morse theorem. All right, so let's keep working. So now we have what? Cos 3 theta. I'm working on getting the real term, all the components of the real term. Now note here that if I square this, I'm going to get I square sine square. But I square is equal to -1. So that will make this minus 3 cos theta. Sorry, before I do that, before I write the cos theta, minus 3, yeah, minus 3 cos theta sine square theta. What happened? When I square I sine theta, when I square that, I'm going to get I square sine square theta. But I square is equal to minus 1. So the entire term is going to become minus cos theta sine square theta. All right, let's get the terms in the i's. And this is now plus 3I cos squared theta sine theta. Now, I sine theta cube, if I cube that, I'm going to end up with I cube sine cube theta. Now, I cube is equal to minus 1. I cube would be I square times I. That's I cube, but I square is minus 1. So I cube is just simply minus I. So this is going to be minus I sine cube theta. Let's spell it out. So this is going to be equal to cos 3 theta minus 3 cos theta sine squared theta. Over here, I is common. I'm only taking out the I plus I, and then inside I'm going to have 3 cos squared theta sine theta minus, and this is sine cube theta.
Excuse me, sir.
Uh-huh.
Sorry for cutting in every minute, but can you let me in, please?
I just did. All right.
Okay, sir.
So,
Sir, and one more thing, isn't it supposed to be cos 3 theta plus 3 cos theta sine square theta plus negative 3i? Since the I squared is where you have positive.
all right. Which line are you talking about? This line?
So the second line.
Shouldn't it be the second line? Where?
So we have.
Keep
So
going.
remember, you start off with 3 cos squared theta times I sine theta. I is
Yes.
not squared right there. So how
Yes.
did it become negative?
You know, it isn't negative. See it here and it's positive. This is it here now and it's positive. So it is actually this.
Oh, that is what I was looking for. Also, you put that one before.
Yes, that's all I did.
Okay.
All right. All right, so let's finish this up. So now I have a complex number on the left being equal to a complex number on the right. Now, when two complex numbers are equal, this is cos 3 theta plus I sine 3 theta. Now, when two complex numbers are equal, the real part on the left is equal to the real part on the right. So the real part on the left is cos 3 theta, and that is equal to the real part on the right, which is cos cube theta minus 3 cos theta sine squared theta. Now, the question said you need to write cos 3 theta in terms of cos theta only. So I need to get rid of the sine square. This is equal to cos cube theta minus 3 cos theta. Now, sine square theta is the same as saying 1 minus cos squared theta. Anybody have any problems with that? No? All right, I don't think anybody should. This is going to be equal to now cos cube theta applying distributive law, I get minus 3 cos theta. A negative times a negative is a positive. And then now this is what? 3 cos cube theta. So this is going to be equal to now cos cube theta plus 3 cos cube theta is 4 cos cube theta minus 3 cos theta. And this is cos 3 theta. So cos 3 theta is equal to that. Now, so that is using the real. Now the imaginary part on the left, which is sine 3 theta, is equal to the imaginary part on the right, which is 3 cos squared theta sine theta minus sine cube theta. They need it in terms of sine theta only, so I need to get rid of the cos square. This is 1 minus sine square theta sine theta minus sine cube theta. All right, so distributive law. Please note you're applying distributive law from two ends. You're multiplying by the 3 on the left and the sine theta on the right. So this is going to become 3 sine theta minus 3 sine cube theta minus sine cube theta. So our final answer is sine 3 theta would be equal to 3 sine theta minus 4 sine cube theta. And what we just did is we just used the Moore's law to express cos 3 theta in terms of cos theta only and sine 3 theta in terms of sine theta only.